Okay, so this one is a little bit more interesting. Okay, I'm going to call it again d of n, and this is going to be equal to something. Okay, so I start with my first term, second term, third term, fourth term, fifth term. Okay, so these are my terms. Okay, so how can I get the 3? Okay, so I would think 2 plus n squared. Okay, this is how I'm going to get the 3. How? If you plug 1 here, you have that 1 squared is 1 plus 2 is 3. 2 squared is 4 plus 2 is 6. 3 squared is 9 plus 2 is 11, and so forth. So this is going to be the pattern. Please remember, you need to find the pattern. Okay, so for the other page, what you have over here is if n is greater than 0, and please note that n needs to be greater than 0. Okay, it's an integer, it cannot be a fraction. Okay, the factorial symbol, what we call the factorial symbol, this symbol that you have over here, is defined as follows. 0 factorial, by definition, is always going to be 1. Okay, 1 factorial is always 1. Now, what is the meaning of this crazy notation that we have over here? Okay, so what n factorial means is that it's going to be n times n minus 1 times n minus 2 times blah, 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 2, 1. Okay, so it's going to be from n, okay, up to positive 1. Okay, and you're going to multiply all these numbers. Okay, this happens if n is greater or equal than 2. Okay, so for example, let's look at examples. This will make your life easier. Okay, if we want to find 5 factorial, 5 factorial is going to be equal to 5 times 4 times 3 times 2 times 1. That is 5 factorial. Okay, so you're going to multiply each one of them. So 5 times 4, you know that it's 20. 20 times 3 is going to be 60. 60 times 2 is going to be 120. 120 times 1 is 120. So that is 5 factorial. What is going to be 6 factorial? It's going to be 6 times 5 times 4 times 3 times 2 times 1, which you know that it's going to be 720. Okay? Now you're going to tell me, what is n factorial? Well, we don't know what's n. Okay, so we can always say that n factorial is equal to n times n minus 1 factorial. Do you agree that in this case, this is the same, 6 times 5 factorial? Well, this is what we're saying here. Okay, so in general, this is always true. Okay, so another way to define sequences is to write them, what we call it, recursively. Okay, this means that we are going to assign a value to the first term and specify the nth term by the formula or equation that involves one or more terms before it. Okay, so for example, if we need to write down the first 5 terms of the following recursive defined sequence, I'm giving you basically the first value, okay, and then I'm giving you the formula for the rest of the values, for the second term, the third term, and so forth. Okay, so what I have is that S1 is 5. Okay, so if they want the first 5, what do you know that it's S2? S2 is going to be equal to 2, following the formula, times S2 minus 1 is 1. So do you know what's S1? Absolutely. Okay, it's 5. So you have that it's 2 times 5, which is 10. In the same way, you can find S3. S3, following this formula again, you have that it's 2 times S3 minus 1, which you know that it's S2. So it's going to be 2 times S2, which is 10, equals 20. Okay, the same way you have S4 is going to be equal to 2 times S3, which you know that 2 times 20 is going to be 40. Okay, and then we have the last one, S5 is going to be equal to 2 times S4, which is going to be equal to 2 times 40, which is going to be 80. Okay, so your first 5 terms are going to be 5, 10, 20, 40, and 80. Okay, please note something. If you messed up here, then you are going to have everything different. Okay, that's the bad part about this. Okay, And this is not the only way to write sequences recursively, okay? Another example here, we need to write down the first 5 terms of the following recursive defined sequence. Here I'm defining my first term, my second term, and then I'm giving you the formula for the third term and on. Meaning, okay, here they are asking about the 5 terms, so I already have number 1, term number 2, I already have it here, which is 1. Okay, now if I want to find u sub 3, okay, it's going to be what? U sub 3 is going to be equal to, in this situation, is going to be u1 plus u1 plus 1, okay, because I'm plugging a 1 here, you want the 3 here. So if n plus 2 is equal to 3, what's n? You start n equals 3, okay? So that's why I know that this is 3, and that's how I have this 1, and this is going to be a u2, okay? So you have u1 plus u2. What's u1 plus u2? 1 plus 1, which is 2. Okay, so this is your third term. Okay, so for the fourth term in this situation, what you have is going to be u4, and it's going to be u, okay, 2, okay, because this is 2 less, plus u3. This is going to be equal to 1 plus 2, which is equal to 3. u5, that it's my fifth term, is going to be equal to u3 plus u4. And this is going to be equal to, it's going to be equal to 3 plus 2, which is going to be equal to 5. Okay, so the first 5 terms are going to be 1, 1, 2, 3, 5. Okay, so those are going to be the first 5 terms. We call this one the Fibonacci numbers, okay? By the way, if you remember the golden ratio, that's the Fibonacci sequence, okay? That's what we have, okay? So let's continue learning more about sequences, okay? Often we want to find the sum of the first n terms of a sequence, which is a 1 plus a 2 plus a 3 and so forth. Rather than write down the terms, we are going to use this notation, okay? I'm pretty sure you have seen it before and we're like, wow, that's something super difficult. Actually, it's not. It's just the addition, okay? What it means is that you are adding the first term up to the nth term of a sequence, okay? The symbol sigma is the Greek letter sigma, which is S in our alphabet. In mathematics, it means to sum or to add terms. Okay, then the integer, in this case k, is called the index of the sum, and it tells you which term to start. In this case, you start at 1, and which one to end. The starting point is here, the end point is there. Okay. So this, when you read this, what you are seeing is the instruction to find the sum of the terms of ak of the sequence an, starting from the first term, which is 1, and ending with the nth term, which in this case is n. Okay, so we read it as the sum of ak from k equals 1 to k equals n. Okay, so if you want to use the summation notation for this one, what you are going to do here is, if we want to generalize this, okay, you know that this is the same as we start at 1, so you plug the 1 here. Okay, so that's going to be your first term of the addition, then you add, and then you increment. What's the next integer after 1? 2. Okay, so it's going to be 2 divided by 2 plus 1 plus 3 divided by 3 plus 1, dot, 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 dot. When are you going to end? When at n, okay, so you have that it's n divided by n plus 1, and that's going to be basically your addition, okay, that's going to be your result. Okay, so let's look at this one. What are you going to do here? If you see here, we started at 1, here we're starting at 0, so you plug the 0. So the first term that you have for this situation, it would be 0 squared minus 1, okay, plus, then it's going to be 1 squared minus 1, okay, then you have plus, and then it would be 2 squared minus 1 plus dot, 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 and the last one that you have is n squared minus 1. Okay, so this is how I write it, with the dot, dot, dot. okay? So you don't write every single term. What I do usually, I write the first 3 terms and then the last one, okay? So if we need to express each sum using the summation notation, okay, so you need to see the pattern. That's what we were talking about, patterns. Okay, so what do you see that it's changing? This 2 is the same, right? Do you agree with that? This one is the same, okay. So what it's changing, it's the 1, the 2, the 3, the 4, the 5. Okay, so what are you going to do here? Well, you know that it's a summation, okay, because you see the plus, plus, plus there. Okay, where are you starting? You are starting at basically k equals 1, okay, because this is 1. You are ending at 5, okay, and your formula here is going to be 1 over k to the power of 2, and that's it. Okay, so pretty simple. Don't overcomplicate the situation. Okay, let's look at this one. Okay, you're going to tell me, okay, so 1, 3, 5, and then I have this formula. This one is super helpful. Why? Because you are like, okay, so it's the addition starting at 1, k equals 1, and then what's going to be that? Well, I'm not sure. Okay, so if you plug 1 here, what do you have? 2 times 1 minus 1 is 1. Do you agree with that? So score. If we plug 2 here, what do you have? 2 times 2 is 4 minus 1, 3. Score. Okay, so what do you have here? N. Okay, so the formula is going to be 2k minus 1, and that's it. Okay, so don't let the notation to intimidate you. This is the collection basically of sums of addition. Okay.